Hey everyone, thanks for your attention, thanks for coming. It's nice to have a lot of people here with attention with the EVM Sidechain. My name is Ferran, I'm the CEO of Persys Technology, the company that is working on building the EVM Sidechain together with Ripple Labs. And with me it's Adrià Carrera, who's the CTO and the guy that does and the architect of most of the product and the solution. So today, since this is more a technical workshop, I will let Adrià explain most of the parts. I wanted to join in the start to set a couple of points. This is the contents that we will see today. I will jump first a little bit on say why do we need the EVM sidechain and why this is an amazing and unparalleled opportunity for everyone at XRPL. We have a talk later around 5:45 p.m. in the afternoon only dedicated on why EVM Sidechain is important and why do we need EVM Sidechain. That's actually the title. So I will make a very quick intro here. But then I will let Adrià explain the EVM fundamentals and how to join the EVM sidechain, even if you are a node, even if you want to be a validator, a developer, a user, or any kind of way that you want to join. And we will give you all the links and the public documentation. So just 2 slides on the talk that we have in the afternoon and why we need the EVM sidechain and what are the opportunities. I guess this is the main 4 advantages of EVM compatibility. That is the right term to refer to it. The first one is portability. Thanks of being EVM compatible, it means that any application on the blockchain space which is EVM compatible, which turns to be out of almost, of them can launch or migrate their actual smart contracts to the EVM sidechain with minimal code modifications. This means that any big DApp that wants to launch in such a big ecosystem, top 5, top 6 ecosystem as it is XRPL right now, they will be able to do it in a very few time and with almost no cost. This is the reason also there is another point called lower cost. It's not also migrating cost, but also it's how to build things there. The good point of EVM compatibility is that probably it's the biggest and by far the most used standard in the blockchain industry. So there's a lot of tools, a lot of smart contracts. We all think that it can be difficult to make a smart contract, that it has some risks, but the reality is that most of the tools that you will need to use on the smart contracts are already done, are just reused. You can import these libraries that has been audited and used many times. So effectively, normally the costs of developing something on top of EVM, it's considerably lower. It is interoperable also instantly with all the chains, which is also a very good point. The software that is EVM compatible, it's EVM compatible with all the chains. So it means like just by having an EVM compatible chain, all the Metamask users that are tens of millions with 1 click can access to your product. So basically you can offer your DApp to all these users and you can reach mass adoption quite more easily. And very related to that is this user base of the blockchain space. There is around 100 million unique wallets right now on the blockchain space, or something around that, and most of them are accessible through EVM compatibility, as well as in the development space with different numbers, but a lot of development and the apps are around this side. So I think it's EVM compatibility, it's clearly a winner decision and a winner point to have for the XRPL. And if we combine the power, the security, the XRP token, and all the features that XRPL have combined with EVM compatibility, I think it can lead to an unparalleled growth for the ecosystem in terms of adoption and in terms of usability. The main opportunities for the 3 main stakeholders, in my opinion, are the same. This is a screenshot taken, I guess, yesterday. I think for the apps, this is a sweetie. I think for the apps that are launching in the EVM ecosystems that normally are launching in the top 20, top 30 chain, the top protocols, if you have the chance to launch in such a rich ecosystem and such a big ecosystem as XRP, just by being EVM compatible, it's an opportunity that you should take. All these apps are in Ethereum, are in BNB. Actually, if you see the list on Bitcoin, probably you cannot do many things. Tether is the token, so effectively XRP is the third biggest ecosystem. And I'm sure most of the apps want to launch there. If it's EVM compatible, it will take you very minimal effort to launch here, so I think you should go for this opportunity. And the main value, and the only actually which make it important, is that the native currency of the EVM sidechain is XRP. If you have a new chain, but the token is not XRP, then the main value that we are seeing here, which is actually XRP, it's set of the security, it's set of the safety, the liquidity, and the amazing effort that Ripple has done and many other entities during more than 10 years to bring XRP here. If you don't have XRP, then you lose 99% of this boundary. So I think having XRP as a native token, even if also creates some conflicts or some difficulties in terms of incentivization, it gives the real value for the most used apps. For developers and the people that will attend this workshop, I think it's also a very, very unique opportunity. You can start now, you don't need even to be too much creative. You can build things that worked in other ecosystems and put your brand and your things here and potentially will work, right? And this is an example from Avalanche. Avalanche, it's an EVM chain. Joe, it's from Trader Joe. It's a protocol that it's literally a copy of Uniswap with different front end and stuff. They launched on Avalanche and they had 83 million. Right now they have 83 million market cap. Benki, it's very similar to Aave protocol, and they have 20 million market cap. And all these apps are in an ecosystem which is 10 times smaller than XRP. It means that if you multiply these numbers per 10, you can reach a very big potential. Because the apps will take some time to operate here. So the developers that just makes these first parts of the niche of the market, I think they can launch very successful apps. Also, any app you launch on the EVM sidechain, you can offer potentially to most of the users on the ecosystem, and you can potentially monetize most of the money on the ecosystem. I think right now the market is 1 trillion, except Bitcoin it's $500 billion. And if just taking the top 10 protocols, which all of them are EVM compatible or have an EVM compatible chain except XRPL, they made more than 400 billion. So almost you are targeting the entire market. And for users, I think there will be also a very big opportunity. You will see in the afternoon, but only on Polygon there is more than 37K dApps that potentially can migrate and can launch here. Probably will not have all of them, but hopefully as much as possible. Or you can migrate, you can bridge your XRPs to these other chains and interact with them. So you will have a new environment to operate. You will be able to interoperate with more than 700 EVM blockchains with its own protocols, with its own dApps. And I think it's an unparalleled opportunity, and hopefully Adrià right now will show you how to join, whether you want to run a validator, whether you want to build a app, or whether you are just a user, and how to benefit of this innovation. So, all yours.
Thanks, Ferran. So before getting in the practical side, we need to understand a little bit the theory, what are the fundamentals of our EVM sidechain. Basically, I prepared 2 slides, one for the network and one for the bridge, since they are separate components, but both of them are really important. So let's start with the network technical details. We'll get a little bit into theory here. We have to think that the network itself, or the blockchain, it's split into 2 layers, what we call the consensus layer and the execution layer. Basically, the consensus layer, it's a layer that's responsibility is to maintain a state machine replication. What does that mean? Basically, each node on the network has its own state machine, and this state machine is replicated across all the network. So the consensus layer must ensure that this machine is synchronized all the time, and it's also live. It doesn't go down, or it doesn't halt. Right? So this is the main goal of the consensus layer. While the execution layer, it's to implement this state machine. replication or the state machine itself. So on the consensus side, we have the Comet BFT engine, which is a fork from Tendermint. Tendermint is pretty popular and it's very well used on lots of blockchains on the space. It's a BFT consensus engine. What BFT stands for, it's Byzantine fault tolerant, meaning that it can support up to 1/3 of the network failure or acting maliciously. And it has one block finalization time, which is quite similar that we have on mainnet, which is an incredible feature. It can support up to 16K TPS. There's a disclaimer here. This is only for the consensus layer, not on the execution. So the consensus engine can support up to 16K TPS, but when we add the overhead of the EVM on top of our consensus layer, we get this TPS amount reduced by a factor of 16. It's just 1K TPS. We are doing efforts to increase that one, but with the 1K TPS, it's a really good metric for an EVM sidechain. On the execution layer side, this is where the state machine is implemented. We are using Cosmos SDK, which is a really popular framework and goes really hand to hand with the Comet BFT engine. This Comet BFT framework, it's adding modular architecture for building your blockchain, so you can have kind of a set of modules and you can plug and play those modules. Also, Cosmos SDK offers models such as the governance model, the slashing model, lots of models that are quite useful when maintaining a blockchain. And then we have additional model, one that's bringing the EVM compatibility called Ethermint. Basically, it's one Cosmos SDK module that implements all the EVM logic, all the EVM, the Ethereum virtual machine. And last but not least, we have the proof of authority module, which basically it's a module that we have implemented. It's a Cosmos SDK module that implements the validator election. Proof of authority module basically implements an authority on the blockchain that it's involved in the validator election. So all the people that wants to run a validator must be inside this authority, and this authority is a democratic authority that decides what validators have voting rights. So we have to think about kind of a DAO, for example, which is a decentralized democratic authority, and basically we have a set of operators, a set of participants inside this authority, and any one of these participants and any participant on the network, in fact, can raise one proposal for adding a new member on this authority or removing one new member of this authority. So anyone can participate on it, and the people inside the authority can vote for this proposal that has been raised, and if the proposal succeeds in terms of votes by a majority, then a new validator can be added on this authority or removed. So this is on the network technical side. Now let's see the bridge. I will go quite briefly here. There's a huge topic inside the XLS 38D. In fact, this is an amendment that's awesome. What we have done for the EVM is basically implement this XLS 38D in Solidity in a smart contract way. XLS 38D is a kind of a standard, a conceptual model. So it can be implemented in RippleD, which is what the amendment is doing, and it can be implemented also in Solidity or in other popular language in blockchain, such as, I don't know, Rust for Near or other popular blockchains. We have done our own implementation on Solidity. And basically, for doing that, we have changed our signer list, the signer list features that we have on XRPL. It's not available on EVM, so we had to use the Genosis safe, which is a really popular also standard for creating these multi-sig accounts or these signer list accounts, and for managing the witness servers and so on. And basically, it's exchange bridge object that the standard defines. It's a smart contract that has access to this Genosis multi-sig account through a module, which is a feature of this Genosis safe smart contract. And then in the middle, we have these witness servers, which basically what they do is listen for events happening one side and attesting what they see on the other side. So if I see one commit event on the XRPL, the witness server will attest this event on the other side. And once enough attestations have been collected and a consensus has been reached, then the unlocking of the funds happen on the other side. So all of this is already live. There's public DevNet resources available. Here are some list of the resources. We have the Explorer, where you can see and monitor all the transactions, block producing, and so on. We have the bridge, where in a user perspective way, you can connect your wallets and you can operate bridge transactions for transferring XRP and transferring tokens. We have a public RPC that will help you guys developing your own dApps. In terms, if you don't want to run your own RPC or your own API, you can use the public RPC, which will work quite amazingly. And then we have some decentralized applications and tools that the community has already built, such as, well, the Gnosis Safe and Cosmos Explorer. Those are the ones I explained. We have also XRP domains that have done a version in EVM, which is pretty awesome. You can create your own domains and just use them for transferred domains and so on. And we also have cookie swag made by Hazard Cookie as a proof of concept for a decentralized exchange where you can add liquidity and then you can swap tokens and so on. Very amazing. So let's go into more the practical side and let's see how we can join the EVM sidechain. You can join the EVM sidechain in lots of ways. Going from a really user perspective by using the EVM sidechain as a user, connecting, creating your wallet, interacting with dApps and so on, and unlocking all the possibilities. You can also use the EVM sidechain to build your own features, your own dApps as a developer, or you can also join the EVM sidechain as a validator. So we'll try to cover all those quite quickly with the time we have. And the first thing we have to do, in fact, it's install Metamask. This sounds quite obvious, but since Metamask is not a wallet that's used for XRPL community, I thought that explaining how to install it and how to add the network is quite useful. So let's do it. I've prepared my browser here. So the first thing we have to do is go to metamask.io and download it and install it in Chrome. Metamask, it's a wallet that uses, it's useful for all the EVM compatible sidechains and works in all of them. There's a little trick in terms of when installing the network itself, because you have to add the custom network, since Metamask doesn't know all of them. In this case, we're going to create a new wallet, pretty straightforward. I agree, whatever, super secure password. And yeah, just create wallet. If you have to do that with real keys, you should backing up your wallet and so on. And in our case, we're not going to do that. Yeah, I would skip. Got it. Next, done. All right, so now we have our Metamask installed here. I can add it on my, all right. And we can see, all right, got it. We have our wallet installed, and we are connected with Ethereum. We don't want to be connected with ETH. There's another network. So we are going to add our own network. And how to do that? There's a tab here for selecting a network. It's good enough. All right, and you can add a new network. And now here on the bottom, there's a network manually. And if we click that button, we are able to add our own network manually. So here, we will call that XRPL EVM Sidechain. And in the RPC URL, you have to input the RPC that I showed on the slide before. It's rpc-evm-sidechain.xrpl.org. We have to add the chain ID, which is 144302. All right, and the currency symbol, which is XRP. Since the native currency of our sidechain is the same, is XRP, in fact, our native currency in our MetaMask will also be XRP. And also we have to add the block explorer URL, which is basically https evm-sidechain.xrpl.org. So, oh yeah, thanks. All right. So now we have added our MetaMask, and we have been connected to our network. Switch to XRPL sidechain. Yes, we don't have XRP because we have not claimed that. So the next step is to claim our XRP using the bridge. So we have a fancy UI, as I told you before, for operating the bridge in a user perspective. We can go to this URL and use the bridge. We have to connect both wallets, Metamask and Faucet, and then select the token to transfer and so on. So if we go here, that's what I didn't want to. Give me 1 minute. Sorry. OK. Yeah. Got it. bridge.devnet.xrpl.org. All right, here we have the bridge. All right, so we have to connect both wallets, one wallet for the XRPL side and one wallet for the EVM side. On the EVM side, quite easy and straightforward. A MetaMask pop-up will appear asking to link our account. In this case, we accept all these messages, and we can now create one Faucet wallet. Now, since the amendment is not yet on the mainnet, the chain on the XRPL side that we are connecting with is a DevNet sidechain. So on the DevNet sidechain, we have a Faucet, and we can easily create one wallet there and claim funds. So we have added this option to make things more smoother. But in the future, once the amendment is ready to be in the mainnet, we will add your favorite wallets here, and you will be able to add which wallet you want. So now we're going to transfer XRPs from the XRPL DevNet to the EVM sidechain. If you can see here, I have quite a lot of XRPs claimed by the Faucet. If I wouldn't want to transfer XRP and I want to select a token, I can also transfer 2 tokens that we have created, USD, which is an IOU created originally on the XRPL chain, and PER, which is a ERC20 originally created on EVM. In this case, you can transfer the XRP. Let's say I want to transfer 100K, which is this. I basically click the button transfer, and here I have to sign one transaction on the Faucet wallet. This is actually doing in an automated way because the Faucet wallet is already controlled by the UI, so we don't want to annoy the user a little bit. And yeah, the transaction is processing. We can go to see the explorer of the EVM side, and we will see that the transaction has been done correctly. EVM Sidechain XRPL org. Good. It's not this one. Or it should be. What is it? Oh, it's this one, yes. Yeah, it's this one, right? Yeah. So I have received, no, not this one. This one, sorry. Someone's using the bridge right now. So yeah, I have received here 100,000 XRP, and I can check my MetaMask, so I will now have XRP on my account. So what I can do now is play with the EVM sidechain, just pay the transaction fees with XRP without having to switch back to another currency and so on. And once I'm done with that, if I want to go back to the main chain, I just can create one new transaction, but the other way around, from the EVM sidechain to the XRPL DevNet, and I can transfer back my XRPs to the main chain. So I have also the ability to be there if I want as a user. I wouldn't do that now because that would take much time, and we're running a little bit out of time. So now we have our XRP. We can start doing things. We can transfer our XRP, or we can create the apps. So what about if we create the apps as a developer? So the next step is develop our first decentralized application. I will explain here how to deploy a custom token using Open Zeppelin standards and Remix, which is an online IDE really good for creating POCs and so on. And then we will try to create our first Solidity smart contract and deploy it and verify it if we have time. And yeah, so to do so, we'll go to Open Zeppelin, which is an organization really popular for providing standards on EVM, such as the ERC20s and the ERC721s. They are the developers of it, and they have public documentation and so on. So if we go to the docs, here in our products, there's the smart contracts section, and there's a wizard, which I find this tool really interesting if you want to deploy if you want to deploy ERC20s or any other standards quite easily, and it's quite configurable. I don't know why it's so hidden, because it's so amazing. So we can create our Apex token here and have it as symbol as APX, and let's say we want to pre-mint 10K, it's fine. We don't want any of those feature, mountable, vulnerable, any of those. So yeah, once we are done, we can open in Remix, and this basically will trigger up a new tab. Will trigger a new tab. Oh, not yet, no, it's not working. Why is not? Let me refresh that. This is not made by us, so no, I'm not worried. All right, now? All right, now it's working. So this will open up this new tab with using Remix IDE. This is an online, as I said, an online IDE, really powerful for creating proof of concepts, not really end projects, but proof of concepts. So now we have this token. I will rename that as Apex token. That's not needed, but just for organization terms. Great. And now we can go to this section and compile our token. So we are taking this Solidity code and compiling it to a bytecode, which is the code that the EVM can read. And then we are going to deploy that. To deploy that, here we can choose the network where we are going to deploy. In this case, we're going to use Metamask for deploying, so we are going to deploy it on the EVM sidechain. We connect the Metamask, and that's it. I don't know why it's 0 Ether. That's a Remix problem. Oh, now it's updated. All right. You can omit the Ether part. This is Remix stuff. So we can deploy our token. And a new transaction is triggered from our MetaMask, calling, hey, do you want to sign this contract deployment? In this case, we want to sign it, so we can click on confirm. And if we go to the Block Explorer, we will see that the transaction appears here. As we can refresh. All right, so there's a new token created. There's the Apex token has been created, and this is the amount of supply. Here you have to take into account that tokens on the EVM have 18 decimals, so that is why there are so many zeros. But in fact, it's just 10K. Now we have deployed our token. We can add this. This is the new address of our token, and we can add that on MetaMask if we want. In MetaMask, there's a tab called Tokens, and here you can import your own custom tokens. In this case, I will add my contract address, which is APX, and I import it. And MetaMask shows me correctly the amount of decimals, so I have 10K APX tokens here. What we can do now? So now let's try to develop quite a more complex application, which I have prepared a token sale. I have not written it, but we can do it quite quickly. So we have to create one new file, which I will call Apex token sale. That's all. And I will use this as a guide. All right, so we're going to import our Apex token by writing Apex token. All right, this is not an ERC20, it's a different contract. And we will have one variable on the smart contract, which will be referring to the Apex token. For example, we can call it like this. And then on the constructor, we will give the address of our token. Token address. We can remove this. And basically, we will assign the variable on the constructor by telling the smart contract to make one Apex token equal Apex token, the address given, which is the token address. Great. And now we will add one functionality so that people can execute this function, pay some XRP, and get some Apex token back. To do so, we are going to create one function that we will call by token, for example. Token. And this will be a public function, meaning that anyone can call it, and it will be payable. And what we will do is trigger one operation on the Apex token, which is transfer. So we are going to transfer tokens from the smart contract to the sender of this transaction. So in this case, it's message.sender, which is the destination of the token transfer, and the amount, which will be the message.value. So this means that for each XRP that you send to this function, you will receive one Apex token. Yeah, this should be working, if I don't see anything wrong. So we can deploy that. We can compile this one and deploy it using the same, Apex token sale, the same method we used before. So in the deploy script, since on the constructor we are giving one address, we need to specify the address that will be here. In this case, we are going to use the address of our token that we have just created, which is this Apex token. And we will specify that here and confirm. And voila, we have the smart contract deployed on our sidechain. So now we can do one offer sale. We can validate this smart contract and verify it. Yeah, I think we have time for it. So for doing that, the Remix IDE is showing us there's an artifacts and build info. So we have to create here one JSON with the standard input.json. And we have to take, where does it go? What is it? Oh. That's the JSON. All right, now. And we have to take this one, this field here called input. We have to take this field, put it here, OK, whatever, and download it on our file. Good. And now we can go to the Explorer. And the Explorer doesn't know which smart contract, what does this smart contract, because this is obfuscated through a bytecode. So the end user will be able to audit the function of your smart contract, probably. So you have a functionality on the Explorer where you can verify your smart contract and publish it, so anyone can audit and can trust this smart contract. To do so, there's a button called Verify, where you can add your standard input JSON that we have just created. Here we have to add the contract name, Apex token sale, the compiler, which it's the 18 version, and here we can add this standard input and verify and publish. Input struct. This is direct. Maybe I have to remove this one. Yes. Good. Let's try again. Let's try again and verify. Good, we have it. So now we have the smart contract publicly available on our Explorer, and anyone can go to the Explorer and read this function, this smart contract we have created, and check that the functionality does what we are saying. So we can trust the publisher of this smart contract. We could also use the Explorer to interact with a smart contract, but with basically using the function by token as well. We can connect Metamask here, connect, and we can buy some tokens. So here I can specify, for example, that I want 10. No, this is not possible. So this is a limitation on the Explorer. We have to imagine that there will be a fancy UI if I create my own DApp, so I can implement my own front-end, cool front-end, and so on. In this case, I have to pay XRP, and the Explorer is not allowing me to do so, so I will use Remix. That's also a possibility. And I can call the buy token functionality. In this case, I will add here a value, which I will send, for example, 100 XRP to get 100 APX tokens. And I can call this function, and amount exceeds balance. All right, I have to send APX tokens to the smart contract. but I don't have enough time, I think. All right, so let's jump on the next one. Basically, I have to send this ERC20 to the smart contract, and then the smart contract will have this token, so I will be able to buy them. But let's skip that for now, because the next topic is really interesting, and it's how to operate the network by running a node. Now, we have seen the user, the developer, and now let's see the operator perspective. It's quite easy, and you will see that now. We will do it. For showing this demo, I have prepared one virtual machine. Well, not virtual machine, actually. It's a Hetzner machine, where we can going to connect to it. This one. Can you read? I'll put it bigger. Yeah. All right. For guiding this, we have public documentation, which is quite useful. It's on open source. I don't have the link right now. Next slide. This one. Good. Not good. Oh, it's broken, the link. Yeah. Sorry. It's this one. OK. opensource.ripple.com/docs. Here we have a EVM sidechain and run a validator category. We can click on join the XRPL EVM sidechain. OK, so the prerequisites of this is just having Docker on our machine. So I will have to install it. apt update. And yeah, and after we have Docker, we are going to create one alias called XRPD, which will be the daemon for running the EVM sidechain. And basically, this alias, it's calling Docker run container. So we are going to execute everything inside the Docker container, and this alias will be really useful for doing so. All right, so I will install Docker. Yes. And then we can create this alias. So all the time I now, if I say XRPD, now, well, the first time I execute this command, I have to download the image of the Docker. And now I have the command for running a bridge. So it's as simple as this when installing the validator node on your machine. Now let's configure our node so we can run our network. So the first step is to configure and say which chain ID are we going to connect with. Doing so, we run this command, no problems. Next one, we are going to create the validator keys. This needs to be secure. In terms of our sidechain, since this is a DevNet, we can, and our demo, we can use the K-ring backend test, which basically will say that it will save the keys on plain text. Not recommended for production. Please don't do it, and please don't spam. Don't show here the mnemonic. So now that we have done that, we are going to create we are going to initialize our node, and to do so, init my node, and sorry, and this as well. Good. Now I need to add the Genesis file. I'm going quite fast because I'm finishing out of time. So I have downloaded the Genesis file from GitHub, and I have it here, as you can see. Well, and I can copy this Genesis file to my xrpt config Genesis. So I can replace the default Genesis. I validate the Genesis file, so check that everything is correct. Everything is correct. And I get the peers. This peers list is basically a list that's publicly available of a set of peers that are available in order to start participating on the network, to know who I'm going to connect with. And after that, I can add these peers on my config of the node using this command. And we are going to finish now by starting our node and synchronizing. So voila. Yeah, so we are now synchronizing with the network. It will take for about some hours, I think 3-4 hours to get to the network up to date. So as you've seen, running a node, it's as simple as this. Then we can configure our node in a more, let's say, production-ready set. But this is quite. I just stop it. Don't worry about the error. I click to stop. So it's quite easy to run a node, as you can see, and quite straightforward. And to finish the presentation, there's another tool called the EVM CLI where you can find on the documentation. It's really powerful because you can create your own environments, bootstrap the bridges, and so on. I encourage you to look at the documentation that you can find publicly available here. Documentation has explanations for the bridge, for validators, for EVM CLIs, whatever, and also find us on the Discord channel. And last but not least, I encourage you guys to have a look on our public channels and ping us if you want to run a validator node. We are interested in doing partnerships with new people coming and wanting to participate on the authority. So if you want to participate on the sidechain, please send us an email on here, on my and Ferran. Thank you very much.